In section 8.3, we are going to use the space in example 2 to do this example first before we do example 1. It just makes more sense for what we're doing to do this example first. So if you're watching the video, pause the video, write this down, and then play. This is a 3-variable system. It's a system of equations that has 3 variables, x's, y's, and z's. Sometimes you can use a method called back substitution to solve the system. So we are going to solve this system using back substitution. Basically, a 3-variable system has an ordered triple as the answer. The first one is whatever x equals, the second blank is for y, and the third blank is for z. So it's like an ordered pair of x and y, we just add a third blank and that's where z goes. The nice thing about this particular system is that we already know what one of our variables equals. So I already know that z is -5. Back substitution means take the variable that you know, substitute it into another equation, figure out a second variable, and then substitute both of those into a third equation to figure out the third variable. So if we know that z is -5, we can put that -5 in place of the z right above it and then figure out what y is. So we would do 3y minus a -5 equals 2. That's 3y plus 5. We would then subtract 5 on both sides and get 3y equals -3. So what does y equal? -1. Once we know that y is -1, now we can go to the equation we haven't used and put -1 in place of the y and -5 in place of the z, and then figure out what x is. So we have x minus 2 times our y value, -1, plus 4 times our z value, -5, equals 4. So that's really x plus 2 minus 20 equals 4. And if you're thinking this number is way too big, this can't be right, it absolutely is right. X is 22. Now let's go to example 1. We cannot use back substitution in example 1 because we don't know what one of our variables is. But we do know this middle equation has just x and y. So -x plus 3y equals -4. That's an equation that only has x and y. We want to use the other 2 equations and eliminate a variable so that we have another equation that is just x and y. So we want to use these 2 and get an equation that just has x and y, which means we need to eliminate the z. So if we take these 2, if we need to eliminate the z, my z's are currently 3z and 5z. What do we need to make them become? 15. So if we want the top one to be positive 15, we'd have to multiply that entire equation by 5. Then the bottom one we would need to multiply by -3. So I'm going to do that and write it down below. That would give us 5x minus 10y plus 15z equals 45. And -6x plus 15y minus 15z equals negative 51. So our goal here is to eliminate z. Add them together, we have negative 1x plus 5y, z has been eliminated, equals negative 6. Let's put that up here with the other equation that is just x and y. Ultimately, we need to figure out one variable. So now this little middle column is kind of like the example we did a couple days ago. We have this system that has x and y. We need to eliminate one of the variables. Which of these variables looks easiest to eliminate? I think the x is the easiest to eliminate. What would we have to multiply one of the equations by to eliminate the x? Negative 1. And you can do that pretty easily. If I take this green one and multiply by negative 1, we would have positive x, negative 5y, and positive 6. So you can just go through and change those signs. And now it's ready for elimination. The x's eliminate. We have negative 2y equals 2. So what does y equal? Negative 1. So somewhere on here you want to put your 3 blanks, your ordered triple. We now know that y is negative 1. Now we do basically what we did in that first example that we did together. We back substitute. We know that y is negative 1. We need to plug negative 1 into an equation that has y and one other variable to figure out a second one. Then we plug both of those into an original equation to find the third one. So of the purple and the green, which one would you prefer to plug negative 1 into? I think purple would be good. So if I take this y equals negative 1 and plug it in here, negative x plus 3 times negative 1 equals negative 4. If we add 3 to both sides, we get negative x equals negative 1, so x equals 1. Now we know that y is negative 1. We know that x is positive 1. Now we get to pick an original 3 variable equation to plug those into to figure out what z is. Would you like to pick the original top equation or the original bottom equation? I'm going to go for original top equation because it looks like it's smaller numbers. So that will hopefully give me fewer opportunities to make mistakes. We want to put our 1 in place of our x, our negative 1 in place of our y. So 1, negative 2 times negative 1 will be positive 2. Plus 3z equals 9. So 3z equals 6, which means that z is 2. In example 3, we have one equation that is just x and z, which means we need to eliminate y in another equation. So I have 3x minus z equals 0. In these two equations, I need to eliminate y. And I'm very happy to see that they actually are already perfectly set up for y. So I'm going to recopy them down here. X plus y plus z equals 6. 2x minus y plus z equals 3. Add them. We have 3x, y eliminates, 2z equals 9. And I'll bring that up here and add it to my other equation that just has x and z. Now I need to eliminate something else. We could multiply the top equation by 2 and eliminate the z's, or we could multiply everything in one of the equations by -1 and eliminate the x's. I think multiplying by -1 means I have to show less work, because if I multiply by 2, I have to like rewrite them. So I'm going to multiply everything by a negative and make this -3x plus z equals -0, which by the way is still just 0 because -0 doesn't really exist. If I add these, the x's eliminate and I have 3z equals 9. And that means that z is 3. Now that I know z is 3, I'm going to use one of these other equations. Do you care which one I use? Top purple or bottom purple? Top purple. So if I use this equation with z is 3, I'll use the original version. The original version was 3x minus z equals 0. So 3x minus 3 equals 0. X equals 1. Then we need to go back to one of the original equations, and I definitely am going to pick x plus y plus z equals 6, because that looks like a pretty simple equation to deal with. I know that x is 1. We don't know y. Z is 3. So y plus 4 equals 6. That means y is 2. For your assignment, I would like you to focus on number 2 and number 8. Number 2 is like the first example we did today. Number 8 is like the second and third example that we did. Number 10, you don't need to worry about yet. However, if you want to write number 10 at the bottom of your assignment, like just write the problem, tomorrow we're going to start class by doing number 10 together, and then I'll give you a worksheet to practice 3 variable systems. So we are going to do number 10, we're just going to do it together tomorrow.